Hello and welcome to our next video in this topic on light. So last lesson we looked at light and how that it is a transverse wave, and we spoke about how light could only travel in straight lines. So building on that, today we need to look at what's known as reflection. So today's title in your books, you need to write the title Reflection. You need to put the date in the top corner. By the end of today's lesson, you should be able to define what an image is, you should be able to explain what the law of reflection is, and you should be able to evaluate why some surfaces create a virtual image while others do not. So write this title in your book and we can make a start. So the first thing we're going to define today is the word reflection. Reflection. So, reflection. Now remember, all keywords are in green. You need to write those down in green in your book so that you've got quick reference to them. So we can define reflection as the change in direction, the change in direction of light or sound when it hits a boundary and bounces back. So that should read, I'm just going to tidy up that back because it doesn't look very good. That should read, reflection is the change in direction of light or sound when it hits a boundary and bounces back. So when we see our reflection in a mirror, the light bounces off us onto the surface of the mirror and it is then reflected into our eyes. So we can add underneath here by saying that when we look at ourselves in a mirror, comma, light bounces off us and onto the surface of the mirror, and onto the surface of the mirror. Full stop. We can then say that the light is then reflected off the mirror into our eyes. Into our eyes. Okay? So it should read, when we look at ourselves in a mirror, light bounces off us and onto the surface of the mirror. The light is then reflected off the mirror into our eyes. So that should say then THEN. Okay? So imagine that we've got you looking in a mirror. So this is you as a stick person. Here's your mirror in your house. It's a full body mirror, we'll say. And when we draw mirrors, we always add these dashed lines on the side. So this is our mirror. This is a person, or we'll say you. And we've got a light source in the sky. Okay, so we've got light source in the sky. Now, the light that is produced by the light source travels in a straight line to you. Remember, we always add arrows onto our light diagram. The light is reflected, or it bounces off you into the mirror. If I had a ruler, I would be doing this with a ruler, but it's very difficult to do on a computer screen. And that light then reflects off the mirror into your eyes, and you see your reflection. That's what we've said here. So we can say that these are light rays. We've got the light source producing light. The light bounces off you into the mirror and then is reflected into your eyes so that you see an image of yourself. We say that our reflection is a virtual image. So we can say, and I'll put this in red, that the reflection that we see of ourselves, in a mirror is said to be a virtual image. A virtual image. Okay? Now, if a mirror has a flat reflective surface, it is said to be a plane mirror. So our next keyword is the word plane, and that's P-L-A-N-E, mirror. Okay, a plane mirror. And we can define this as a mirror with a flat reflective surface. A mirror with a flat reflective surface. Don't spell surface with a V, do you? Surface. Okay? Now, if you look at an image of yourself in a plane mirror, it has the same shape and the same size as you. So we can add underneath here by saying that object or images produced in a plane mirror have the same size and shape, as the object. So in a plane mirror, the image produced will always have the same size and shape as the object. So reflection is the changing direction of light or sound when it hits a boundary and bounces back. When we look at ourselves in the mirror, light bounces off us into the mirror and is reflected back into our eyes so that we can see ourselves. The image produced, so the thing that we see in the mirror, is said to be a virtual image. And a plane mirror is a mirror with a flat reflective surface, and that the images produced in a plane mirror have the same size and shape as the object. So if we have a look back at our learning objectives, it says, can you define what an image is? You should be able to do that. We now need to look at the law of reflection. So if we can just refresh our screen so that we can carry on learning, and we can put the subheading, please, the law of reflection. The law of reflection. Okay, and we're going to need an image of the PowerPoint for this. So we're going to copy that and we're going to paste it in. And I'm going to make it a bit smaller because we're going to draw our own underneath as well. So I'm referring to this image that's on the PowerPoint, okay? Whenever we draw reflection, as I said to you earlier, a mirror is always drawn as a straight line with dashes coming off it. Okay? So this is my mirror. In the middle of this mirror, at 90 degrees, we have what's known as the normal. Okay? And we draw the normal as a dashed line, like so. So this is the normal. And we can define the normal as our first keyword on this part. So we've got normal line, the normal line, and we can define the normal line as the imaginary line at 90 degrees to the mirror. So imaginary line at 90 degrees to the mirror. So just to make this a bit more clearer, this is your normal line. And it'd help if I picked the same colour, wouldn't it? So I think we use that one. Normal line. That'll do. Okay. Now the ray of light that comes into the mirror, which we're going to do in yellow, is known as your incident ray, and it's shown up here on this diagram. We always add arrows on our line to show which way the light is going. So this is our incident ray. And that can be our next keyword, incident ray. We can define the incident ray as the ray of light that reflects, the ray of light from the ray box to the mirror. So the ray of light from the ray box to the mirror. That's our incident ray. Okay? Now, there is an angle we can measure here. Hopefully you've done angles in maths. I'm going to presume that you have. And the angle that we can measure is this one here. Okay? Now this angle from the normal line to the incident ray we can show with a little eye. And we can say that the little eye stands for the angle of incidence. Angle of incidence. I'm going to write this clearer up here, so don't worry. The angle of incidence. So here we can put angle of incidence. And the angle of incidence is the angle between the incident ray and the normal line. So the angle of incidence is the angle between the normal line and the incident ray. So the angle of incidence is the angle between the normal line and the incident ray. The final two we need to do is, the first one is the reflected ray. And we can draw our arrows to show it's coming off there. The reflected ray. And we can define this. So over here we can put reflected ray. And we can say that it's the ray of light that reflects off the mirror. So ray of light that reflects off the mirror. And finally, we've got what's known as the angle of reflection. The angle of reflection. And we'll do that with this colour here. And that can be shown with a lowercase r. The lowercase r is the angle of reflection. And we can define that. So angle of reflection. We can define that as the angle between the normal line and the reflected ray. So the angle between the normal line and the reflected ray. So we've got the incident ray, which is the ray of light from the ray box. We've got the angle of incidence, which is the angle between the incident ray and the normal line. We've got the reflected ray, which is the ray of light that reflects off the mirror. And we've got the angle of reflection, that is the angle between the reflected ray and the normal line. So we're shining light on a mirror and it's bouncing off. The important thing is that the angle of incidence, so the angle between the normal line and the incident ray, will always be the same as the angle of reflection. So we're going to write down in red because it's really important. We're going to put the angle of incidence will always equal the angle of reflection. Okay, so the angle of incidence will always equal the angle of reflection. This is known as the law of reflection. So this angle here, the angle between the incident ray and the normal line, will always be the same as the angle between the normal line and the reflected ray. So if this is 10 degrees, this will be 10 degrees. If this is 100 degrees, that will be 100 degrees. If it's 2 degrees, that will be 2 degrees. These two angles are always the same. They're always identical. So if we have a look back to our learning objectives while I have a quick swig of water, it says, can you define what an image is? You should be able to do that. And it says, can you explain what the law of reflection is? You should be able to do that now. You now need to be able to tell me why some surfaces can create an image while others cannot. So while I'm swigging my water, I will re-change the screen. Okay. So, could you put the subheading, please? Rough surfaces. So, rough surfaces. So we said that light is reflected off a plane mirror, and when it's reflected off a plane mirror, the image produced will always have the same size and shape of the object. But some surfaces don't create an image. Light is reflected off all surfaces. However, it might only be a little bit. So we can say in red that every surface reflects some light, comma, but not all of them create an image. Okay? So, rough surfaces scatter light, which prevents an image from being formed. And I think I've got a diagram to help us with this. So, if we can just paste that in, we'll put it down here. It is on the PowerPoint if you want it a bit bigger. So we'll put it here and we'll say rough surfaces scatter light, preventing an image being formed. An image being formed. Okay? So if we look at these two diagrams on a smooth surface, such as a plane mirror, the light reflects off the smooth surface into the eyes of the young boy with the yellow jumper on, and he sees a clear image of himself. The girl looking at the rough surface, although some light goes into her eye so she can see the surface, it doesn't reflect evenly. Therefore, she can't make an image. So a couple of key words just to finish us off. We've got the word scattered. And we can say when light bounces off an object in all directions. So scattered means when light bounces off an object in all directions. We've got the word specular reflection. Specular reflection. Specular is S-P-E-C-U-L-A-R, reflection. And this is reflection from a smooth surface. Reflection from a smooth surface. And finally, we've got diffuse reflection. Diffuse reflection. Clean that up a bit, sorry. So we've got diffuse reflection. And diffuse reflection is reflection from a rough surface. Reflection from a rough surface. So if we look at these two diagrams at the top, we've got specular reflection, because it's from a smooth surface, and we've got diffuse reflection, because it's from a rough surface. So, you should now be able to answer these three questions. You should be able to tell me what an image is. You should be able to tell me what the law of reflection is. And you should be able to tell me why some surfaces create an image while others do not. What I would like you to do now, please, I would like you to pause the video, and I would like you to have a go at these questions that you see on the screen at the moment. Make sure that you have a different coloured pen to hand, because in a moment we're going to go over the answers. I would like that to be a green pen, but if you haven't got one, don't worry too much. So have a go at these questions in your book. For question 1, write it out, fill in the gaps. For question 2 and 3, write out the question in your book and answer it, and then we'll go over the answers shortly. So pause the video now and have a go, please. Okay, so hopefully you should have had a go at these questions that you see on the screen at the moment. We can refresh our whiteboard and we can start going over the answers for these. So if I can just paste in our questions, if I can move this over here so we've got a bit more room. Lovely. So it should read, when you look in a mirror, you see a virtual image of yourself. The image is the same size, shape, and distance from the mirror. When you close your left eye, the image appears to close their right eye. The image is formed because the light reflects off the mirror so that the angle of incidence is equal to the angle of reflection. So question 1 should have read, when you look in a mirror, you see a virtual image of yourself. The image is the same size, shape, and distance from the mirror. When you close your left eye, the image appears to close their right eye. The image is formed because light reflects off the mirror so that the angle of incidence is equal to the angle of reflection. So let's grab the next two questions so that we can have a go at them. I'm going to make these a bit smaller on the screen so I've got room to actually write some answers for you. So the first question says, or number 2 says, draw a ray diagram to show how your image is formed when you look in a full-length plane mirror. So your mark comes from having that the light hits the wall and is reflected at lots of different angles, and the light needs to reflect in a way to form an image. So if we put that into plain English, what you needed to do was you needed to draw a person. You needed to draw your mirror. Remember, your mirror must have dashed lines coming from it to show that it is a mirror. You should have had a light source. If you can't remember what a light source is, you need to go and watch our last lesson on light. And you needed to draw a straight light ray coming from the sun to the person. You needed to draw the light going into the mirror and then being reflected back into the person's eyes. So you get 1 mark for having the light bounce off the person, another mark for light bouncing off the mirror, and the 3rd mark for the light going into the person's eye. Next one. Use ray diagrams to show that you see 4 images when you look at the image of an object in 2 mirrors at 90 degrees to each other. So what you needed was 2 mirrors shown in at 90 degrees to each other. Okay? So you should have had 1 mirror like this and 1 mirror like this. And we can show that they're mirrors so that it's like that. We could have our object here. Okay? Light would be bouncing off our object in all different directions. Okay? So if this is a person, we'll say, we'll just put them at this angle for the ease of drawing it. We would have light bouncing off them from here to here and then back into their eye. And we would also have light bouncing from here to here and back into their eye. Okay? They're going to see multiple objects or multiple images inside the mirror. Okay? So if you think about this, the placing of the 2 mirrors will allow for multiple objects to be seen all at once. Okay? So, you should have drawn something like what is shown on the screen at the moment, although it isn't the neatest diagram ever, and I'm trying to think how I can draw it a bit neater for you. Okay, don't worry too much about that, but essentially what you needed was light rays coming off an object into 1 mirror, light rays being reflected into the eyes of the other one. Okay, and then again you'd need to draw your arrows coming off these ones going into the eyes of this one. Okay, if you're not sure about the answer for this one, it is a very difficult question. Drop me a comment in the Google Classrooms or send me an email and I will sort that out for you. Okay, so you should now be able to tell me what an image is, you should be able to tell me what the law of reflection is, and you should be able to tell me why some surfaces create an image while others do not. Next lesson we will be looking at something called refraction. I will see you then. Take care.